hi there. Thanks for showing up for your learning. Let's take a look at some of the question types that we will be looking at on this week's quiz. So, our first topic is graphing periodic functions. And take a look at the rubric. All right, I can use the features of the function, such as amplitude, period, horizontal axis, maximum and minimum, and phase shift, to graph it. Right? That's, I believe, a really useful skill. You can just work point by point, but I do think that makes it a little harder. And labeling key points with exact values is something that's cool for style points. So we're going to want to see you being able to do that. That is a curriculum skill. So we're going to take a look. All right, on the grid provided, to complete a table of values and sketch two cycles of the function f of x equal to 6 sine, well, I know 6 here. 6 equals the amplitude. So that's going to be my A value transformation. 10 is my K, okay? And I remember that period is equal to 360 divided by K. So in this case, period is equal to 36 because 360 divided by 10 is 36. All right. We've been asked to sketch two cycles, so we're going to need 36 times 2, which is 72 units. And then what's the 6? The D equals -6, and that means phase shift 6 right. So the whole function is shifted to the right. It's kind of, I'm imagining this moving towards the maximum there as it's phase shifting. And then +3. And why is it moving towards the maximum? Because I'm already visualizing that my sine wave does this. So if I move it 6 right that way, maybe that point is going to be my maximum value. And then +3, C is 3. So y equals 3 is my horizontal axis. All right, cool. So let's find our maximum and minimums. That's going to be helpful. Our maximum is going to be the amplitude plus that. So our max is at 9. And our minimum is going to be the this minus that. So it's going to be at minimum is -3. How do I do that? Well, your formula for max is C plus A. If A is positive, that'll give you the max. And C minus A. So plus or minus A gives you the maximum and the minimum. Okay, so that's how you find the maximum and the minimum values. So now just go ahead and vandalize your graph paper with these values. Y is equal to 3, y is equal to 9, and y is equal to -3. So 9 you'll find up here. I'm just going to zoom out so you can see. 3 you'll find, oh man, it's so tiny. And -3 down there. I think I got them. Zoom in. Okay. And then you can zoom into your paper by moving your face back and forth. Sometimes I imagine, how will they do this on the test? And the trick would be to move your face towards your paper or away from your paper. So what I'm doing here is just a dotted line for the horizontal axis. I happen to like the color blue, hence my wardrobe choices and my preferred choice of pen. And then here's the maximum. So I just have these little guidelines. If you didn't want to show these for some reason, you could still do a rough copy and then translate to a good copy somewhere for like your report or something in your university level classes. All right, and then here's the minimums. Are going to be down there. Great. All right. Now let's get a table of values that we can work with. Okay. So label 3 x-intercepts and the y-intercept with exact values. Ooh, okay. Let's graph it first and then figure that out. But we can also just figure out the y-intercept. So let's do, well, let's put together our table. So I'm going to erase some of these little notes that I gave you, and you could do that on the test with an eraser. All right, and let's create a table of values. So we're going to be looking at x and sine x. For our parent function, and I will transform them point by point, sine 0 is equal to 0. Sine 30 is equal to 1/2. Sine 90 is equal to, what is it? 1. Sine 120, sorry, 150 is equal to 1/2. Sine 180 is back to 0. 270 is equal to minus 1. And 360, and we're around full circle, 0. Okay, so I think these values here are enough to give you a really good idea of where your function's at, and they transform nicely because we don't have square roots. But we're going to find that the y-intercept isn't among these because of that phase shift. So we're going to have to calculate that one separately. So then go ahead and calculate your transformed stuff. So I'm just going to, again, remove these. I did that so I can remove it. And hey, I've got a computer so I can do what I want. All right. Okay. Let's just take all that out. I'm going to do some work there. All right. I'm going to do some work there. So here we go. Okay. Now let's transform these points. So we set up our transformation point. We divide x by k. So it's going to be all of my x values divided by 10. And then I subtract 6 from them because that's a weird sign flipper, and we divide by k. So that's going to be how I transform my x values. And then how I transform my y values is I multiply by this and then add that. Those are not weird. So 6y plus 3. Okay, so let's go. 0, 0 transforms to negative 6. Ah, it's off our graph. Too bad. Negative 6 and then 0. 0 transforms to 3. So we can kind of imagine that that's like back here, negative 6 and up there at the midline. And then 30, 1/2. Ah, that's also off our graph. 30 divided by 10 is 3, minus 6 is minus 3. Oh, too bad. 1/2, 6y plus 3 is what? Oh, yeah, so 6 times this is 6. 6 times a half is 3. 3 plus 3 is 6. Okay, then 90. Ah, finally, we're on our graph. 9 minus 3, so that's 3. And then 1. 6 times 1 is 6, plus 1 plus 3 is 9. There we're at a maximum. 150. 150, that's 15 minus 6, so 15 minus 6 is 9. And then 1/2 times 6 is 3, plus 3 is 6. Okay, 180 is going to give us 18 minus 6 is 12, and 0 times 6 plus 3 is 3. 270 is 27 minus 6, that's 21. We're finally hitting a minimum. Minus 1, so negative 6 plus 3 is negative 3. And then 360, we're around to negative 6, 3. Okay, and that will be, I could just add the period of 36 to that, so that should be at 30. Let's check. 360 divided by 10 is 36, minus 6 is 30. Okay, so what I'm noticing now, and then 0 times 6 is 0, plus 3 is 3, okay, is that I went around the circle once. This point, unfortunately, fell off of my graph. But if I just added 36 to the x value, I'd get the next point in the cycle. We took the time to transform that point, so let's just create another point by adding 36. So that would be 33. Negative 3 plus 36 is 33. And then just repeat the y value. Is there 6? Okay, cool. Now let's plot these points. Okay, so we got 3, 9. So 3, 9 is there. All right. 9, 6 is there. And 12, 3 is there. All right. And then 21 minus 3 is there. 33 is there. Okay. And 33, 6. So there's 33, 6 is there. And then let's go ahead and, gosh, we need to find our maximum. Where is that maximum at? So why didn't we see our maximum? Did I not plot it? Oh, I put it in the wrong spot. My goodness. See how valuable? See how valuable that little squiggly line, that little dotted line was to me just there? I had misplotted a point. I plotted that at 3.8 instead of 3.9. Have you ever made a mistake like that? I'm sure you have. And there you go. We fixed it. So then let's add 36 to that. So that would be 39.9. So 39.9 is going to be there. Okay, so that's just adding 36 to that. We now see one full period. Let's go 39 plus 36 gives 75. So we're over here at 75. And we're back up to the top. Okay, let's take this point here, 21 minus 3, and add 36 to 21. So we're going to extend that one by 36, so that's going to be 57. 57 is over here working very carefully down there. All right, good. All right. And then I'm pretty happy with that. 30 plus 36 is 66. So that's going to be there. 12 plus 36 is 48. So it's going to be there. Now, let's go ahead and draw the 2 cycles. Okay. So we're coming up to our maximum. We're going to solve for that later. Don't worry. We'll go down through these points. Come down here. Come up. Hit our points. Oy, it's hard to be beautiful on my technology. Yeah. Okay, all right, I know it's ugly. But anyway, it's okay-ish. All right, and then let's solve for this y-intercept here. Okay, let's find out what it is. We're just going to find out by doing x equals 0 in our function, finding the exact value for that. All right, f at 0 is equal to 6 multiplied by the result of sine 10 times 0 plus 6 plus 3, end that bracket. All right, f at 0 equals, break the bedness down, 6 sine 10 times 0 plus 6 is 60. 6 sine 60 plus 3. Okay, sine 60 happens to be root 3 over 2. F at 0 equals 6. And how do you remember that sine 60 is that? You think about this triangle. Okay, that's 60. That's 2. That's 1. That's root 3. So opposite over hypotenuse is root 3 over 2. Okay, I saw that in my mind, so I don't need to leave it on the screen. And so root 3 over 2. So 6 times root 3 over 2 plus 3. Oh, that's cool. F at 0 is equal to 3 root 3 plus 3. Isn't that cute? Okay, and I like to put cute numbers in there to tickle you. So this is the point 0, and 3 plus 3 root 3. Okay, that's its y value, 3 plus 3 root 3. It's the value of the function when x is 0. And now we want to find 3 x-intercepts. My goodness. All right. Well, let's see. Here is a trick for these ones, is I'm noticing that the x-axis is halfway in between here. So it's going to be sine negative 1/2. Okay, so they're actually integer values for these x-intercepts, and I might do something similar on the test. So this trick is useful. So where is that going to happen? Actually, it should be happening like about there, I think. That should be one of them. Looking at it a little more carefully, and like that should be one of them. Let's find them. Okay, let's see how we would find one of them. So I would let's set our function to 0. We'll do it algebraically. All right. F at x is equal to 0 for some value x, and the function is 6 sine, what was it? 10? Yeah, 10x plus 6 plus 3. Simplify as much as possible. So I'm going to subtract 3 from both sides and then divide by 6. Okay, so I'm going to have negative 3 is equal to 6, but then I divide by 6, so I get rid of it. Okay, is equal to sine of here 10x plus 60. Expand that bracket. All right, now let me break this down for you. Like, I think you can do this in one step too. I subtracted 3 from both sides. That's how that ended up there. And then I divided both sides by 6. So that's how that ended up down there. Okay, and now I do inverse sine of both sides. Sine inverse of this, okay, will give me, just erase my inverse operation, that will give me the value of 10x plus 60. So sine inverse of negative 1/2. Oh, well, that's 330 and 210. Okay, so we get two values, all right? And why is that? Well, you have to have your unit circle ready to go in your head. And if you look at a unit circle, let me just show you one. All right, so recall that the y values here on the unit circle give you the value of sine for those angles. And I see negative 1/2 there at 330 and negative 1/2 at 210. So the answer is all in your unit circle, if you know how to read it well. And you can also get that answer from a sine x curve. Here it is here. If you can just visualize the curve sine of x, or you have the parent function graphed on your cheat sheet or graphed in your brain, then you know that it's hitting negative 1/2 at 210 and at 330. Okay, so what that gives us is two little mini equations, and we're going to solve both. Okay, so let's take that. So this is the solution to sine inverse of 1/2, negative 1/2, that's this. Negative 3/6 is just negative 1/2, is equal to this, okay, because taking the sine inverse takes away that sign. So what we have is 210 equals 10x plus 60. Okay, so we have to make the angle that we're taking the sine of 210, or 330 equals 10x plus 60, and solve both for x. So I subtract 60 from each side, gives me 150, and here x equals 15. Your algebraic manipulations will tell you the same thing. Here 270, so x equals 27. Okay, and then how would I get more x-intercepts? Well, I could add the period, 36. So 15 plus 36 is 51. X equals 51 should be the next x-intercept. And 27 plus 36 gives me 63. X equals 63 will be the next x-intercept. Let's go check. 15, 27. So like I said, my function should be coming down here. So I might now use an eraser and improve it and get it over there. And 27. So 27 is there. So this one should actually be climbing a little faster and going up that way. Yeah. And then the next two were at 51 and 63. So let's see. 51, oh, we hit that one pretty good. 51 is there. And 63, that's when my function got real ugly. So it's going to be there. So I'm going to improve that. And then I would, with an eraser on a test, make that more beautiful and get it through those extra points. Okay. Maybe the application we're looking at involves x-intercepts and we need those values. So anyway, that would be how I would answer those questions and get that graphed. If I wanted to carry this on, yeah, you could keep going, do more cycles of it just by adding 36. What I just did there is really ugly. The whole thing is ugly, and I'm a little dissatisfied that I have an ugly graph there. Maybe I'll create a more beautiful one with more care and precision. All right, bye for now, everyone. I hope that's useful. If it wasn't, hit me up with a question by email. Or your complaints. I can take those too. Bye for now.